We've done a couple of different triangle proofs, and this one is going to be about triangle congruence. By ASA and AAS, and it's really just about exactly the same thing. This will be a really short video. The idea here is, if I have a triangle, like this, and I have my points labeled A, B, C, then I can make a second triangle that's a lot like this one. It can actually be identical to it, and I'm going to have it be identical just so that I can show you what these congruences look like. So I've got this second triangle. Here it is, identical to this one. And I want to show some congruences. So A, B, C, D, E, F. We know these are congruent because I duplicated one to get the other. Angle side angle, meaning I know that angle A is congruent to angle D. I know that angle B is congruent to angle E. And I want to do a couple of different things with this. If I'm looking at angle side angle, then I want to say that side AB is congruent to side DE. If I'm looking at angle side, I've got angle A, I've got angle side, so then I would have to say that this side is congruent to this side over here. Well, these come down to the same thing. What I know is that the sum of my angles in a triangle has to be equal to 180 degrees, or if you're particularly mathy, you might say pi radians, right? I have two angles. Because this angle is because angle A is congruent to angle D and angle B to angle E, and because I know that all the angles inside a triangle have to add up to 180 degrees, I know for sure I can say angle C has to be congruent to angle F. This was my third angle theorem. These other two, these were given pieces. Given. Well, I know my angles are all congruent, and at this point, if I were to stop my proof right here, that would be enough to say triangle ABC is similar to triangle DEF, meaning one is scaled on the other. But now if I can also say that one of these sides on ABC is congruent to one of the sides over here, then that means these triangles are similar, and with one side being congruent, they have a scaling factor of 1. So whether I want to say side AB is congruent to side DE, that's fine. I could say BC is congruent to EF, and that's fine. Or I could say AC is congruent to DF, and that's fine. Any one of those, so I'm going to say or, any one of those is fine. If I've got two angles and a side, that's enough. Now ASA, that's saying the side that I have is the side that's between the angles. AAS means I've got angle, angle, side. So angle A, angle B, side BC, or angle B, angle A, side AC, meaning this is I've got two angles and the side that's not between the two angles. This one says I've got two angles and the side that is between the two angles. Those are my only possibilities. So if I can say that I've got two congruent angles from one triangle to the next and a congruent side, that's enough for me to say these triangles completely are going to be congruent.